Okay, so here's my project. I have a few meshes that I imported into the project from the Egypt package, stylized Egypt package. Just a few meshes. Most of them are from that package. I also imported a few sounds as well. If I go to content, sounds, that one's looping. Um, but yeah. Moving right on to what polymorphism. Uh, I'll use health and yeah. So evil ornament. No, no, that's not right. It's not here. Okay, sorry. Sure. So with healing field, well, sorry, with healed health change, you see health, heal health, and the output is you take the value and you add it to current health and you set it to that value. So whenever we get health change, we're going to be adding it to current health. But over here in take damage, whenever you have the value, it's going to be subtracting from current health. So it means the same thing, but the words are the same, but they do two separate actions. That's why when we add the input health add value, we know that the value is going to be additive. So whatever value is getting sent into health change is going to be positive. It's going to be positive. And whenever take damage is called, it's going to be negative. This, regardless of the input name, though, with the output alone, we know what health change means in take damage. Same for heal health. Now moving on to encapsulation. Um, no, I'll do inheritance. So with inheritance, whoops, I'm gonna stay in health, but I'll be using health and player score. So player health is actually a child of health. So everything health does, player health will also be doing. Um, Move that right here. So in player health, the only thing it overrides is death. But anytime take damage is called, it how player health is going to do that exactly. Heal health is called, it's going to do that exactly. Update HPUI is going to do that exactly. But death is the only one where it's going to run death, then it's going to get game instance and cast a basic level game instance and call the custom event on player death. Because it is a child, it's going to do everything the parent does as long as that's specified. However, the parent isn't going to do anything the child does. I mean, anything the child also does. Uh, I don't know if I said that but right, but like the child is gonna have everything the parent has, but the parent isn't gonna have everything the child has because the child is going to only take things from the parent, and the parent isn't gonna take anything from the child. I think that was a little bit better, but that's moving on from inheritance to encapsulation. So with encapsulation, I think I'll use my component. As you see here, all of these values, all these variables, all these functions, all these there's no macros here, but all these functions and variables are all only going to be called within this class. Anything it needs is only specified within here, right? Um, So like for example, in move direction, it doesn't need to go to like the score class or the health class to get vector direction or to grab that function because the function is defined in this component. And then same thing for this macro. It's not a macro library. It's in this component. Positive movement is a boolean, a variable defined in this component, and so on and so forth for these variables. All of this is defined inside this class, right? And the reason why this is so important is because when you start like um, having variables call, it's okay to have certain things called from other classes as long as they're relevant. However, the issue is it starts becoming more and more complicated and sloppy if you're calling so many different variables and booleans and all those in vectors from different classes, different blueprints. And when it starts becoming messy and sloppy, it becomes hard. It becomes a little bit taxing to read and can become confusing, and that takes away time that you could be doing making new code. So keeping the code organized and simplified is an easy way to avoid wasting your time having to read your code over and over again, right? And as I specified, all these variables or whatever are defined in this class. So like time before moving, stop is can be changed. So like this could be like 10 seconds, and then it'll wait 10 seconds before setting moving to false. So this will no longer run. Then it will wait time not moving. So this is 2 seconds, so I'll wait 2 seconds, and then after 2 seconds, it's going to set moving to true, and it's also going to flip the positive movement boolean. So if it's true, it's going to get set to false. If it's false, it's going to get set to true, like a light switch. Um, and then it's going to call this event all over again. So this is a loop. I don't know how to do loops, but this is basically a loop. So it's going to do this and then loop. Um, and I think for functions, um, I really could have used health here, so I'll probably do that with sorry. First of all, am I recording? Great. So with damaging field and damaging diamond, you can see here that the object calls the function take damage, right? Take damage is part of the health component, this function. And also, it is called in here, take damage, right? Goes to the health function. And the importance of this function really is that we can call this function within this component anywhere, plug in any value, and get the sum of subtracting it from current health. It's a really easy way to access certain inputs that we need, or certain uh, health changes that we need in general, especially if you're doing like multiple if you're doing like many functions that will subtract many different objects and actors that will will take away health from the player. Just having a function that does that for you really saves you a lot of time and probably processing power as well, right? Um, Moving on to the last principle OOP, we have abstraction. Now, abstraction, I'll be using evil ornament. Now, evil ornament has moving, boolean, speed, delta, time before start. Um, Speed is just the value that is gonna be moving at per second. Moving column, the moving component, here it is. This one is frame based because I wasn't sure how to make it move only specific vectors like z, x, or y. I wasn't sure how to make it move only those directions while setting it to speed. So I couldn't get that to work. But for evil ornament, I was able to get it to work. And the reason why, I'll explain that in a second. But with abstraction, right? You take speed and you go into this component. You take speed, you multiply delta seconds, you multiply it, and then you set delta to that. This is just like an easy way for me to reference delta again. But then it goes to frame based to time based, and that's going to normalize the value, multiply it by that value, so speed times delta, and it's going to add it to its location and set it to that location. Because we have speed here, the only thing you need to know when you want to change how fast this object moves is the name of the variable. So if I go to default here, if I set speed to like 500, and I'll toggle moving. If I set speed to 500, you can see it moving at 500 speed. And if I set it to like 200, you can see it moves at 200 speed. making it simple. The input is speed and the output is how fast it's going to move. Making things simple for anyone who's reading the code. I think this was 30. I'll make it 35. But just simple for anyone else who's reading the code and doesn't need to like go into the code to change any of the values or anything like that, right? Um, and also a big important part of the actor, this ornament, when it reaches the next level trigger, it's going to do this once, but it's going to kill the player. It's going to cast the health and then kill the player, right? Um, and then when the player gets killed, it calls the death function, and then the death function is going to call the child player health, and in child player health, it's going to cast two and call that function inside the game instance, which will restart the level and subtract one from the lives if you have a lives greater than zero. Um, and then it destroys the player, obviously, and death destroys the actor. I think I already said that, right? But and I shouldn't have closed that. But um, a big thing is the time base between frame base. Now, the big issue of not doing time base is even prevalent in my moving object, right? So because I'm doing frame based here, the objects are gonna be moving at frames. So if it takes a little bit for my code to start up, or if I get a little laggy for whatever reason, the movement is going to be dictated by that lag or those frames, right? So if I'm moving a bit faster, it's going to have traveled a bit further than it normally does. It's going to it's going to travel if my speed for my net is running at a decent like normal rate, then it's going to move at the normal speed that I want it to do or travel the distance I want it to normally do. However, if I'm a little laggy, it's going to travel less distance than I want it to do, and it's going to create inconsistencies within the code. And it literally does do that within the code. Certain objects will move further than they did maybe the previous instance, or even um, less, move not as far in the next instance that it's ran. While Evil Ornament, because I converted it to time based, it's going to get the delta seconds, multiply that by the speed, and then we're going to take the location it's going to, so that the next level trigger, subtract that and normalize that value so that we can, I think, yeah, normalize it and multiply it by the speed so that we have a way to access the actor's location based off of how much time has elapsed. We have a way to access the time times the speed normalized, and then time times the speed normalized, and that multiplied and added to the actor's location and setting that to the new location, which is in layman's terms essentially is going to be moving based on how long the project has been running, and it's going to update its movement based on how long the project has been running, not how many frames the project is running at, um, which, like I said, prevents inconsistencies within the code. Is it recording still? Great. But moving on, I think I basically covered vector math, right? You can see the speeds being multiplied here, and I think it's being added. It's being added there. I divide the the score gets divided whenever you die, and you have a score higher than zero. So right here, it's going to divide the score, and then there's subtraction right there. But it's gonna take the score, divide it by score divisor, which I think is just two, and then it's going to take score and subtract it from score divisor, so that uh, it's going to get plugged into here and then set score to that value. So those are variables that I use, or That's math that I used. In vector math, I already showed for the time base versus frame base. Now the trigger box. The trigger box is a object that is right here. Whenever it is hit, right, it's going to by the player. It's going to do this one time, so it doesn't like cause too much lag. But it's going to create smoke, play this sound, and then it's going to check: is this the final level? If not, if this is the final level, then just go to the next map. If this is the final level, then we need to destroy evil ornament just to prevent like issues where the player gets killed, could get killed as they touch the end of the level, stuff like that. But the main important thing here is when it gets hit, it destroys evil ornament. That's the main thing, and it also spawns smoke. That's the main. Those are the important parts. And um, also, right, go to next map is a macro that I have set up here. It's going to wait a few seconds afterwards so you can appreciate the sound and smoke effects. But after 1.5 seconds, um, oh, I forgot to add that there. But regardless, the delay um, is going to wait a few seconds, wait that duration, and then it's going to set it to next level. Next level is going to open level by name. So I already kind of showed this, but I can really quick move the player to like, whoops, whoops. Um, what did I just do? Sorry. I can really quickly move the player to like the nose, maybe. I think. Uh uh. Um. Okay, still dies. Sorry, sorry. Let me. So I'm on the head. I touch the component, creates the smoke, and takes me to the windscreen. And then when I click this, returns me to new. And da 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 da. Right. Next level is the next level trigger box works this doesn't work the same, but for level one, it to take me to level one, for example, all I would need to do is go to click on trigger box. All I need to do is change the name, and that will decide what level it's going to teleport the player to next. Sorry. Whoa. Okay. Um. And lastly, I'll look and go back to my game instances. I pulled those up very briefly, but the game instance allows me to create things that I only want called within the game instance, and I don't want them changed um, outside of the game instance, for example. The only way I want these variables changed is if I cast a game instance. And this is very important because what, for example, happens when I want to carry the player over to another level. If I set that variable to like the score component, that value is not going to get saved in between levels. Same thing for lives. It needs to be saved within game instance because game instance is only going to get changed when you call it to change within the game instance. So like lives, for example, lives is only going to get changed here and any other time I do cast to game instance, basic level game instance, so on and so forth. Singletons like this, like game instance, are very important for creating things that you only want referenced one time. And for UI, I think I kind of showed it already, but there's a health, level, lives, and score. But yeah, I think that covers everything. I hope that wasn't too long. I tried to speed it up a little bit, but that's the best I could do while trying to fulfill the entire rubric.